Hello and welcome, ladies and gentlemen. We are looking at getting started. We are in packet 3 now of topic 2. This is in module 1. I know it's a lot. Basically, we're in packet 3 right now. We're looking at getting started. I have to apologize. I used my brother's printer, and I don't know if he has any color because all the stuff that is supposed to be, well, this is supposed to be blue. I believe this is just like a darker, more bold color. These are all super light and hard to see on the video, but the good news is if you're doing this along with me, you should have your own packet, which will be printed out much more boldly, and also all of the figures are nice and dark colored, so we can work with those just fine. So I apologize about that. I will say which questions I'm on as I work through them, but yeah, here we go. So duped. You can use your construction skills to duplicate a line segment inside a circle. So consider circle A, that's this circle right here. Part A says construct line segment BC congruent to AB and circle A so that point C lies on circle A. So the line segment BC means that I need to construct a line segment with one of its midpoints being B and another midpoint being C. And it says that it's going to be congruent to AB, which means it'll be the same length as AB, in circle A so that point C lies on circle A. So I know that my other endpoint needs to lie on the circle, point C. I know that it needs to be on the circle. And I know that the length of the line altogether needs to be equal to the length of AB. So the way that I showed you guys how to do this in class, I'm going to show you again to do it right now. You want a compass, you want to put the point of your compass on B, and then you want to make the length of the entire thing, you want to make the length of your arc here equal to the length of AB. And then what you can do is you can just go ahead and drag that up, okay, so that it intersects the circle. Where it intersects the circle is where you're going to put point C, so then you can use a straight edge. Use a straight edge right here, so that's going to be point C. Use a straight edge to connect these things, and there you go. So that is point C. So that is part A right there tells us to do that construction. Part B says connect points A and C. What do you know about the length of AC? So I'll connect points A and C. And then what do you know about the length of AC? So that's down here now. What do you know about the length of AC? I know that the measure of line segment AC is equal to the measure of line segment AB because, wow, cannot spell, because they are both radii of the same circle. Right? So a circle is a bunch of points that are all equidistant from one central point. So all of these points along the outside are equidistant from A. So a radius from A to B and a radius from A to C are always going to be the same. And if I drew another radius, all of those radiuses, radii, are going to be the same length as long as we're talking about this circle. So I know that it's equal to AB. So then now question C down here, what type of triangle is ABC? Equilateral. And then explain your reasoning. So I know that, so I constructed BC so that it was the same as AB. So I know that AB, the measure of AB is equal to the measure of BC because I constructed it that way. And I just said that line AC, the measure of AC, is also equal to AB. Whoops, sorry, I was off the screen there when I was writing that, my bad. So I know that's equilateral. I said that AB is equal to AC, or BC, because I constructed it that way, right? And then I know that AC is equal to AB because they're both radii, which is what we just talked about right here. So I know that all three of these are equal in length, and when we have a triangle with three side lengths that are all the same, it is equilateral. Okay. So then, what do you know about the angle measure of ABC? So about the angle measures of ABC, they are all 60 degrees. So if you remember, so equilateral triangles have all equal side lengths, and triangles have the sum of their interior angles. So if I take all of these angles and add them up, it's going to be 180. And because it's an equilateral triangle and all sides are the same, all the angles are going to be the same. And because it adds up to 180, 180 divided by 3 is 60, so all of these have to be 60 degrees. Okay? So they are all 60 degrees. So now, okay, looking at 3.1, this video is going to be getting started as well as activity 3.1. So here we go. 3.1. So it says, not only can you copy a line segment using construction, remember that you can also copy an angle. So it asks us, number one, duplicate angle B, verify with patty paper. So unfortunately, I was kind of ill prepared. I don't have any patty paper with me. as you can imagine. I didn't have this printed out. I had to print it off on my brother's thing. Anyway, I don't have patty paper with me. So I'm going to duplicate this. And I can't check it with patty paper, but I know, you know, in my wise 24 years of living, okay, I know that what I'm doing here is correct, so you can just go ahead and believe me on that if you would like. So I have point B here. I'm going to duplicate angle B up here. So the first thing I need to do is I need to put my point of my compass on point B, and then I need to make an arc that is shorter than the length of this line, of these lines that are provided for me, because I need to work with the intersections. So if I make it too long, you won't be able to see any intersections, so I want to make it nice and short like that. And then I want to drag it across so that it intersects both points here. Now, without changing my arc, without changing that distance right there, I'm going to put my point on B down here now. I'm also going to construct a little arc there, okay? So now what I need to do, okay, so what this does, and I explained this in class, but I'll explain it again. Okay, so what this does, it ensures that from point B to here, if I said this point C, and maybe I called this point A, okay, it ensures that from point B to point C is going to be the same distance. And so now what I need to do is I need to quote unquote measure the angle. And the way that I'm going to do that, I'm going to put the point on C. And the reason I'm putting it on C is because I have C down here. You could put it on A, but then I would need to label this A, and then I would need to work down on the angle, if that makes sense. Anyway, so because I'm working from C here, I'm going to work from C there. So I'm going to put my point on C, and then I need to adjust the length of my compass so that when if I were to drag an arc that intersected, this other line, that these two arcs that I construct intersect at a point at point A. So I need to make it so, sorry, that was a little confusing. So my point of my compass is on C, and I need to make my arc long enough so that when I construct that arc, when I draw it, it intersects with my original arc, which is this one, okay? That it intersects with my original arc at point A, right? And so what I've done essentially is I've measured this angle, right? So you can kind of see if I put my compass up to that, I've like measured this angle. So now what I need to do is I need to put my point on C down here, and without changing my arc, draw that same, or without changing my arc, construct another line there. And so where those two intersect is where I'm going to have this duplication of an angle. And my line was a little wonky there, not quite perfectly straight because I missed the straight edge apparently. But you can see that this would be like point A, and then these two angles would have the same angle measure. Okay, so now that was part one. So now part two down here asks us to do the same thing, only it asks us to construct an angle that is twice the measure of this angle A, and then explain how you perform this construction. So again, you just want to start with a straight line, and then I'm going to go label that A because I'm duplicating this angle twice. Okay, so I'm going to do the same process. First thing I need to do is just construct an arc. So I need my point on A here. And then I need to just construct an arc that is smaller than the lines that are provided for me so that I can have an arc that intersects both lines of that angle. So now what I'm going to do the same thing for A here, only I'm going to make this construction a little bit larger. And the reason I'm doing that is because I'm going to need to have two of these angles that I'm constructing down here, whereas before I only needed one. Okay, so now I have both these arcs. So now again, I need to do the part where I am quote unquote measuring the angle. So if this helped you with the last one, okay, this first part that I did ensured that this distance from A to B is the same as this distance from A to B. And now what I need to do is measure this angle with my compass. And the way that I'm going to do that, I'm going to put my point of my compass on B, and then I'm going to make sure that when I construct an arc here, I want to move my compass in such a way that when I construct an arc, it intercepts on our angle line there, which you can see that it does. Okay, so now without changing my arc of my compass, I haven't done anything. I'm going to construct from B, I'm going to put my point on B, and I'm going to make another arc. Okay, so if I were to draw a line, which I will go ahead and do right now. Oh, I dropped my ruler. Here we go. If I were to construct a line from A through this intersection, this would be one duplicate of the angle A, right? But I need to draw an angle that has double this measure. So there's a couple things that you can do here, from here, okay? And if your arc, so if this arc goes farther this way, you could, still having not changed your arc from when you measured the angle, you could go from this intersection, from this intersection, put your point there. Sorry, I know that's in shadow. Put your point on this intersection and then construct another arc and then draw your line through there from point A through there. Or what you can do, another way that you could do it, still this is my arc measure right now is the measure of the angle. I can go on point B again and then just go, instead of going up and constructing and I'm sorry, I'm kind of off the screen. It was all in shadow there. I apologize. It's a little hard with the constructions too. This is also part of why I've done them in advance, is because it gets a little like the shadows are kind of crazy. Anyway, so now I have another intersection down here. And so what I've done is I've constructed 2 of angle A. Right? So this top part from this line, so from AB up, is one duplicate of this angle A, and from AB down is another duplicate of this angle A. So the angle here, from the top one to this bottom line, is going to be double the angle. And then it says explain how you performed this construction. Well, I just did the same. I did the same as a single duplicate, like I did up here. I just did it twice. And so either you did it twice by going 1, 2, or you did it twice by going 1 up, 1 down. Either way works. You could go down twice. You could go there and then there. Either way is fine with me. So that is how we would duplicate that. So now that was 3.1 number 2. So now on to 3.1 number 3, and I apologize again about this printing so strangely, but I can read it, and like I said, if you're working along in your packet, you should be fine. So question 3 says, how is duplicating an angle similar to duplicating a line segment? How is it different? So I would just go like this, similar, and then different, right? So it's similar, use a compass, right? It can be as simple as that. That's one way that it's similar. If you have another way, you can go ahead and list that. One way that it's different, line segments only require 1 arc per duplicate, I guess, if you want to be really official, per duplicate. Angles require 2 plus, right? Because if I were to duplicate it a single time, so if I have a line segment and I want to duplicate it, it takes 1 arc. If I have an angle and I want to duplicate it, it takes 2 on the first one and then 1 more for each additional duplicate after that, right? Like once I have the measure of my angle on this arc, I can just go 1, 1, 1, 1, 1, and I can duplicate it as many times as I'd like. So there's that. Just as simple as that. Again, if you have more similarities or differences that you see, you can go ahead and list those, but those are the ones that I'm going to have here. So 4 says, in the getting started, which is what we just did, you constructed an equilateral triangle ABC. Duplicate the 60-degree angle measure shown, which is this one, to construct 5 additional equilateral triangles that share the center of the circle as a vertex. What do you notice about the polygon you constructed? So the way that I have to do this one, and it seems a little silly, but so when I duplicated an angle, okay, so say I was going to duplicate this 60-degree angle, and I was going to do it down here right below the circle, I have to start with a straight line, and then I have to have a point, and then I have to put my point on construct an arc that's smaller than these 2 line segments. I'd do the same thing down here, then I'd measure the angle, and then I'd plop that down here. Well, the thing that's different now is that my straight line that I'm constructing it on, instead of having it down here, the straight line that I'm constructing it on is right here. It's AC, and then I'm going to go counterclockwise and then counterclockwise again and again and again. So the way that I'm going to do this to save myself some work is, and I'm going to kind of do some crazy rotations here, is I'm going to construct a smaller circle inside of this larger one. This is called a concentric circle. Oh, and let's see, hang on. Here we go. I can never do this without having to stop multiple times. Here we go. Perfect. Okay. So what I've done is I've made a smaller circle inside of this big circle, and the reason that that's going to help me is that now when I measure my angle, so when I go right here and I put my point right there, right? And I measure my angle. Sorry, there we go. And I measure my angle. So that's like, it looks like it's a little big. I adjust it down just a little bit. Perfect, okay? So now this is the angle of this is a 60-degree angle, is my arc measure that I have here, right? So now what I can do is I can just go to this intersection, and I apologize again for the shadows. I can go to this intersection that I just constructed, go boom, that'll be a 60-degree angle. Go to this intersection, go like this, boom, that's a 60-degree. And then I can just do that 3 more times. 1, 2, and then if you do this correctly, hopefully on this last construction, on this last intersection, your line, and so mine wasn't exactly perfect, it was very close though. If you do it exactly right, what's going to happen is this last construction of your arc is going to intersect exactly on the circle and your first angle line on angle, or on line segment AB. So you can see that mine isn't exactly perfect, but it's pretty darn close. So we can go ahead and call that one good. So yeah, so we want to duplicate this to create 5 triangles. So what I'm going to do is, from point A, I'm going to make all the radiuses that I just got intersections for. Right, so right now I'm just putting my pen in part A here, and then I'm drawing through all of these intersections. Like I said, if you do it perfect, the last one will line exactly up with AB. So I'm not going to draw one that just barely is off. I'm just going to leave it as it is. Okay, so you can kind of see this starting to look like a pizza, but it wants us to construct triangles that are congruent to this one. So now I need to go, so I have all of these intersection points here now. Now I want to connect all of these points to make them triangles. So now I'm going to go from point C to here, from here to there. I'm busy. And then there to there. One more. That was my housemate beckoning me, but he just hears me. He thinks I'm in here talking to myself, but actually I'm in here making YouTube videos, so little does he know. Anyway, so you can see now, okay, I've constructed 5 congruent triangles, and you can see that even though I was very slightly off here, that this, like, to the naked eye, looks like a pretty normal polygon here. Okay. So then, yeah, so we did that. 5 additional equilateral triangles that share a center of the circle as a vertex. What do you notice about the polygon that you constructed? So, well, it looks like a polygon, and it looks like it has 1, 2, 3, 4, 5, 6 sides. 1, 2, 3, 4, 5, 6. And if you remember, a polygon that has 6 sides is known as a hexagon. So that would be the shape that we constructed there. Yeah, so there you go. It looks pretty good. I hope you guys have a wonderful evening. I will be posting probably another 1 or 2 videos tonight, so I hope you guys are keeping up with that. Good luck on your homework. I will see you all in class. Have a wonderful night. You're all wonderful people. Adios.